So first, just a little bit for those of you who may not know what is the field of neuroeconomics. The way that I think about this field is an attempt to try and integrate insights from economics, psychology, and neuroscience around how people make decisions, how we behave in groups, our altruistic or selfish actions with respect to each other, and recognizing that all three of these fields are interested in the question of how people make decisions, but often the three each kind of bring a unique lens to it. So economists are often of the three, the ones who are most interested in questions of how, given a goal, how should people reach that goal? How should they make a given decision if they have a certain goal? Psychologists are often interested in understanding what cognitive processes are going on in people's heads, which sometimes is not something that's so much of interest to economists. And neuroscientists are, of course, bring the angle of what's going on in terms of brain processes while people are making decisions. And so the field is really an attempt to try and integrate these three lenses. If you were at Brain Camp 10 years ago, most of what I would have talked about would have been influences that sort of flowed in this direction. We have theories from economics or psychology about how people make decisions, and we're going to use those theories to help plan investigations to understand what's going on in the brain to make decisions. And one of the things that I think is exciting and where I think a lot of the progress has been recently over the last 10 years is really in terms of influences flowing in this other direction. So how there are findings with respect to neuroscience that have implications for either psychology or economics. And in particular, I'm going to talk about thinking about how to organize this, a 15-minute progress talk. What I'm going to give you is really just two deep dives that give you examples of how neuroscience data can predict variables that economists are interested in, and therefore give you a sense of how the influence is flowing the other direction. So the first of these, the first sort of advance in terms of things that were not in the neuroeconomics lecture at the first Brain Camp, but if I were to give the lecture again today, it would be in them, is that neurobiological data can predict individual differences in decision making. Couple examples here. These are, I could pick many examples, but I'm going to talk through a couple from my own work. People differ in how they value the future. So we give people decisions where they have to make trade-offs between smaller amounts of money now or larger amounts of money later. People differ in how they make these trade-offs. Some people are very patient and willing to wait for future rewards. Other people are more impatient and want the money now. And these differences in how people value the future are reflected in persistent structural and functional features of the brain. So this is just a picture from one of our studies, which shows all of the areas of the cortex where the thickness of that cortex is related to how people make these trade-offs. And in all of these cases, less thick cortex predicts a more impatient decision-making. And this is in a sample of mostly adolescents between the ages of 13 and 20. And so we can look at their brain and say something about, make predictions about how impatient they're going to be with respect to the future. People also differ in their tendency to seek or to avoid risk. People are more risk-taking or risk-averse. This is the first question that your financial advisor is going to ask you when you're making your selections for how to invest your retirement account. What's your aversion to risk? And we know that persistent structural and functional features of the brain also reflect these differences. This is another study that we've done in my laboratory where the features about the amygdala and its connections to the medial prefrontal cortex are predictive of people's tendency to seek or to avoid risk. So things like the functional connectivity that Jeff was talking about earlier between these regions, things like the amount of gray matter in the amygdala, these are predictive of people's tendency towards risk aversion. And so this has led some people to speculate going forward that maybe these measures of structural and functional features of the brain could be used to, in the same way that right now we might use personality tests to either sort of select people or in order to sort of maybe make those decisions with respect to how you should invest your money. I think this is really futuristic at this point, so I want to say a couple of things about where we are in terms of predicting individual differences. On the side of caution, I would say that if I wanted to predict whether you are going to be impatient or not, the first thing, the most predictive thing is going to be your past behavior. So if I have your past behavior, that's going to be the best predictor of your future behavior. And probably if I have a really good personality inventory, that's going to be more predictive than what I could get out of a brain scan. That said, on the other hand, there are things that we worry about because they're predictive, and we think about because they're predictive of individual differences, that brain scans, the data I've talked about, brain scans do better. So genes is something that we worry about in terms of, like, do you know my genetic code? Like, do I share my DNA? And that might reveal something about my personality. In terms of predicting these individual differences in decision-making tendencies, brain scans do better than having your full genome in terms of the amount of variance explained. We also worry about things like just demographics, like, people will, make inferences about your risk-taking tendencies based on whether you're male or female and how old you are. Brain scans do about as well as those demographics, and in some cases a little better than those demographics. So just to sort of help to tell you about what the level of predictive power is within these brain scans. And so I think for the people who are worried about things like privacy, obviously an issue is, lots of people are coming in for brain scans for different reasons, there are inferences that we might be able to make, statistical inferences that we might be able to make from those brain scans that you might have for other reasons. The second advance I want to talk about, again, in this theme of neurobiological data predicting things at the economic level, is that we now have pretty good evidence that neurobiological data can predict market-level economic behavior. So let me talk through what I mean by that. This is a slide from the original Brain Camp, where the point I was trying to make here is that there's a couple of regions of the brain, the ventral striatum shown here on the right, and the ventromedial prefrontal cortex shown here on the left, where when you measure the responses in those regions with functional MRI, there's a greater response in those regions when you receive something rewarding or pleasurable compared to something that's less rewarding or less pleasurable. And we've seen this. This is from a meta-analysis of many studies, over 100 different studies of this form of comparing brain responses to rewarding things or pleasurable things to less rewarding things or less pleasurable things. There are lots of examples of this. So if we give people money, if I give you more money and compare the brain response to giving you more money to less money, there's increased activity in these regions. I can also show pictures of attractive women to heterosexual men, and that causes an increase in activity in these regions. I can give drugs to drug users, and the receipt of those drugs causes an increase in activity in these regions. I can have you listen to your favorite music, and music that you like causes more activity in these regions than music that you don't like. So the thing I like to say is that these are areas of the brain that help you recognize all the pleasurable things about sex, drugs, and rock and roll. This is at the time at which you are consuming these items, but these areas also respond at the time at which you're prospectively evaluating these items and making decisions about them. So there's another set of studies. This, again, I think was probably a slide I was able to show you at the initial brain camp, or maybe 2 or 3 brain camps in. The same 2 regions also respond to a greater degree when you're evaluating things that you like, compared to, there's more activity in those regions than when you're evaluating things that you don't like. And this, again, is a meta-analysis across, I think at the time, 20 or 30 studies showing these robust, reproducible responses. But the different kinds of examples here are, in the domain of food, people might have different preferences over candy bars, but if I ask you to evaluate how much would you pay for a candy bar that you like, there's more activity in these regions than for ones that you don't like. If I ask you to think about taking a gamble, gambles that you find desirable elicit more activity in these regions than gambles that you find that are less desirable. If I ask you to evaluate consumer goods, again, the same principle applies here. And so I think where we left things off at Brain Camp was sort of raising this possibility 10 years ago. Maybe we could do some mind reading here. Maybe if these areas respond more when you're evaluating things that you like better compared to when you're evaluating things that you like less, maybe we could take the response in those areas and make some inferences about what it is that you like and don't like. Maybe we could do some mind reading. And I immediately raised that possibility and then subsequently said, wait, before, you need to, this is not, certainly what you couldn't do, which people were starting to do at that time, would be to put somebody in a scanner, show them a picture, have you look at a picture of your iPhone. I see that you looking at that picture of your iPhone gives you activity in the ventral striatum, and then I say, haha, you love your iPhone. That would not be an inferentially correct type of study to do, nonetheless that people were trying to do them. I would still sort of caution you against that kind of reverse inference, which is just assuming something about cognitive activity from merely observing brain activity. And this is one of the famous papers sort of raising this specter of reverse inference. Now, the take-home of this paper is that you can't just do that. What you have to do is actually do the study in which you, and this is one of the advances Jeff was talking about in the morning. You have to actually do the study where you say, if I measure brain activity here and I try to prospectively predict, things that you like and try and discriminate things that you like from things that you don't like, can I do that? What's my accuracy if I try and predict that from brain activity in the ventral striatum and the ventromedial prefrontal cortex? And when we left off at Brain Camp, people were just starting to do these studies, and it looked like maybe it actually worked in this case, that you could infer from brain activity what people wanted and liked. And one example that had existed at that time was from Greg Burns and colleagues. He had done a study where people were listening to different kinds of music. These were adolescents who were listening to different kinds of music. They were bands that at the time were unknown. These same 2 regions, the ventromedial prefrontal cortex and the ventral striatum, were more active for the music that the adolescents evaluated as being more pleasant, that they liked better. And 5 years later, Greg was able to come back. This was actually sparked by the recognition that some of the bands that he had used as stimuli had subsequently gone on to become famous. He was able to go back and show that activity in the ventral striatum was correlated with, this is now activity as a function of the song, was correlated with how many sales of that song there were. And so what I would have said 5 years ago is, boy, this is really interesting. Maybe there's something here, but this is one study. And I think in the last 5 years, there's now, and notice, one of the things that's really interesting about this is that it's not just, which I think now is really well known, that I can measure the ventral striatal activity in you and predict what you like. I can measure the ventral striatal activity in 30 adolescents and predict what thousands of adolescents like. And that's blew my mind at the time. I would have been buying shares against this replicating about 5 years ago. But we now have about half a dozen conceptual replications in different domains. Emily Falk, who's here at Penn, has shown that neural responses during anti-smoking ads predicts how many people will call in response to those ads for the 1-800-QUIT line. Vinod Venkataraman, who's across town at Temple, has shown that neural responses during ads predict ad elasticity, so ad effectiveness, better than other neural measures and over and above kind of standard focus group type measures that a marketer might use. Brian Knudsen at Stanford has shown that neural responses, if I take the web page from kiva.org and I measure neural responses while people are reading that web page, I can predict which appeals will get more people donating compared to appeals that will be less effective. Emily's had other studies like neural responses to New York Times headlines predict which ones go viral. Brian's had other studies showing that neural responses on crowdfunding, when people read the appeals on a crowdfunding website, will predict which appeals are more successful. And now there's been more than a half dozen of these, such that there are now reviews. I think the question is not, does this work? But the question now is, why does it work? And under what conditions does it work? And what are the boundary conditions? And under what conditions is it better than other measures that you might take? And under what conditions is it giving you similar sorts of predictions that other measures might take? And so I think that's one of the really most interesting advances in this field over the last 5 years. And I will leave it there and take questions.